Okay, we are finally going to jump into more just solving equations that we see with inverse trig functions. We are also going to talk about more exact values, converting things into algebraic expressions, and then just kind of using some of the properties that we've learned about. So very first thing, find the two acute angles in the right triangle whose side lengths are 8, 15, and 17. And you guys should know how to do this. Even if it's been a really long time, you should know how this works. So remember, the longest side is always your hypotenuse. And then the short sides, it really doesn't matter which one goes where. Take your pick. Okay? Just doesn't matter. And then you can name the two acute angles whatever you want. Alpha and beta is like the most common, but it really doesn't matter. And then you have a plethora of choices of how you could go about solving this. Personally, for some reason, I like tangent. I don't know why. It doesn't matter. But I would say, like, okay, the tangent of alpha is always going to be my opposite over my adjacent, which would then be 15 over 8. And then, so that means that tangent of alpha, inverse tangent of the tangent of alpha would equal the inverse tangent of 15 over 8. And we put that in our calculator, and it tells us that alpha is about 61.9-ish degrees. Oh, it says 2 decimal places. So I guess we should do what it says and do 2 decimal places. Where did my calculator go here? There it is. Okay. So let's pull this back up. Okay, so it actually wants 2, so I guess I'll go ahead. First of all, make sure you're in the right mode, okay? Because I was in radian, I need to be in degree, and I need the inverse tangent of 15 over 8. So 61.93, it looks like. 61.93-ish. Okay. And then for beta, again, I don't know why, I just always use tangent, but you can use whatever you want, it doesn't matter. This one would be 8 over 15. So in my calculator, I'm going to do the inverse tangent of 8 over 15. And that hopefully will give me, good, okay, so that's going to be 28.07. And you should notice, okay, so that's beta. You should notice these should add up to 90 degrees. If they don't, we did something wrong, okay? All right, so now that we have that, we need to be able to figure out all the other angles too. So the reference angle of pi fourths that's in quadrant 2. So what this means is if we're in quadrant 2, so I'm going to draw 1 and 2. You'll see why in a second. So if you're saying that the reference angle is pi fourths, what you're saying is that this right here is pi fourths. So here's the reference angle that is pi fourths, okay? But that is not necessarily what we would call that angle. The angle, how we would describe it is we would say, okay, from 0 to here is what angle, and then the reference angle for it is that pi fourths. So what is this angle? The way that we find that, well, we would take pi, and we would minus that pi fourths of our reference angle, and that should give us this one over here. Okay, so we do pi minus pi fourths. So to do that, we would say, okay, well, that's going to be 4 pi over 4 minus pi over 4, which is 3 pi over 4. Now, do you actually have to write out the algebra of pi minus pi fourths? No, but you do need to know how you're thinking about that, right? So this whole thing would be pi fourths. You want to go back pi fourths. That's 3 pi fourths. Okay, all right, so same reference angle as 5 pi 6, but in quadrant 3. So this one's a little bit tricky to like think through what it's saying. So 5 pi 6 would be over here. Actually, I need all 4 in this one. Okay, so 5 pi 6 itself is like right here, right? This is the angle 5 pi 6. Now, the reference angle for that would be right here, and it would be equivalent to the pi minus 5 pi 6. Of course, that's just pi 6, right? So our little pi 6 pink angle here is that. But then wants that same reference angle, but in quadrant 3. So what I want is I want the angle that's down here, but I want this to be the same as this one up here. And the question is like, okay, but then what is this angle, right? So how far did we have to go? Well, you can think about it this way. This was a whole pi, and then I went another pi 6, right? So pi plus pi 6 is 7 pi 6. Okay. And now it wants to give it to us in radians. Okay. So this one's a little bit weird. So, okay, let's go ahead and draw this one. So negative 1.5 radians. Okay. This is a little bit strange because we think of radians as like using pi's, right? So if it's negative 1.5 radians, what that means is that we had negative 1.5 pi over pi, and those canceled out to give us this negative 1.5. Okay. But you can think about it like this as a 1. Okay. And I think sometimes that helps you guys. So negative 1.5 over 1. So we want to go negative 1.5 radians. Okay. So negative 1.5 divided by pi is like negative 0.47 or whatever. And I just want to point out that negative pi halves is like negative 1.5. Okay. So where would this be, right? Okay, I'm going to try and do another way that might help you guys think about this. Try to convert it into what would be degrees to help you think about where this would be. So negative 1.5 radians times by 180 degrees over pi radians. So if we do negative 1.5 and times it by 180 and then divide it by pi, that is like 85-ish degrees. Okay, so like a negative 85-ish degrees. So negative 85 degrees would be like right here. Okay, like almost to negative 90 degrees. Okay, so this right here is negative 1.5 radians. Okay, that's what we already know. Now it wants that same reference angle, but in quadrant 2. So remember the reference angle is always that between the angle, the terminal side of the angle and the x-axis. So I want this same angle, but I want it over here. Okay, so then this would be this angle, and it's going to be pretty close. Right. Sorry, I'm trying to get it to line up, and it's not cooperating very much. Okay, so remember with this pink one, this is kind of misleading. So I'm going to erase that, and I'm going to talk about this. So this reference angle is here. So this reference angle would be here. Okay. But the question is, well, okay, but what's this angle in radians, right? So the way that we do that one, in my mind, is we would take negative 1.5 and we would add pi. Okay, so the reason I say we would add pi is because we'd go from here and to here. That is 180 degrees. That forms a straight line. So that is going to give us, from negative 1.5 up to that, is going to give us the proper angle. So when we do this, negative 1.5 plus pi in radians, I like to think about this as like a 1. Okay, so this is negative 0.5 pi's. No, I don't like that logic. I don't like that explaining. So let's just go ahead and do it this way. So negative 1.5 plus pi is about 1.6. Let's see, does it say? Rounded to 2 decimal places, so 1.64 radians. Okay, so 1.64 radians is going to be right here. And that makes sense. If you think about it, like pi over 2 is right here, so that's 1.57. So 1.64 is like just a tiny bit past it, right? 1.64 radians. Okay, So here's another one. Hopefully this one makes more sense too. Okay, so we've got the same reference angle as 2 radians, but we want it in quadrant 4. So 2 radians ends up being over here. Okay, this is 2 radians. So the reason that it's over there, okay, think about negative 1.5. That's like not quite through, right? So let's do this. Let's turn it into degrees again, just to help you visualize what this should be. So really that's going to be 360 divided by pi, right? So that's 114. Okay, let's just say 115 for the sake of what our brain is trying to do. So if this is 90, right? This is 90. We got to keep going. This would be 180. Okay, now it's obviously going to be closer to 90 than 180, right? So specifically, if you wanted to think about it like more precisely, so 25 degrees past here, okay? 25 degrees past there is where this one's going to be. So it's like, I don't know, right here-ish, okay? This angle is 2 radians. Okay, and then we need the same reference angle. So the reference angle would be this one here, right, down to the x-axis, which means we would want ours, if we're in quadrant 4, the reference angle would be right here, but the angle I'm actually after would be this or this, okay? Now, both of those would fall into quadrant 4, so I don't know that there's necessarily like a right or wrong answer of if you should do the positive version or the negative version. My inclination is to do the positive, but you can kind of decide what you like better there. It doesn't specify. It just says find the indicated angles. It doesn't say that there's a domain restriction or anything like that, so it really doesn't matter. So what I would do is I would do 2 radians plus another pi radians, because again, this is a straight line, okay? And I would just do the pi plus the 2, and that comes out to 5.14 radians, which you probably could have done without a calculator, right? Hopefully. There we go. So that's how we kind of figure out reference angles, okay? So hopefully that's all review. Like none of this should have been crazy new information. So then, how we actually use that when we're trying to solve equations and approximate solutions, if we have that the sine of x equals 7 over 11, then in theory, we would need to undo the sine part to get x by itself, right? So we could take the inverse sine of this side, and we could take the inverse sine of this side, and assuming that x is within our domain restriction, which for sine is all real numbers, so obviously it is, x would then equal the inverse sine of 7 over 11, right? So then, does it say if we're in radians? Okay, so it lies in the interval 0 to 2 pi, which tells us we need to be in radians, so make sure that our mode is in radians. I had to switch mine. So the inverse sine, of 7 over 11, okay, comes out to be, it says 4 decimal places, so 0.6898 radians. And this should be an angle measurement, so it should either be degrees or radians, one of the two. Okay? But, way to think about this. Where could sine be positive? Sine could be positive here or here. All students take calculus, right? So this is true, that for it to equal 7 over 11, it would be over here. This is the one we did, okay? So sine would be 7 over 11. Perfect. But there is another angle in which this is true for. Oh gosh, don't know what happened there. There's another angle that this is true for. this would also be, oh goodness, what am I doing? This would also be 7 over 11 and give us a positive answer. Well, crap, what do we do then? How do we know which one we just found? So this is the one we just found, okay? We also need to think about this one, though, which is why we did all of this, because they share a reference angle, right? So how would we deal with that? Well, think about this. How do you get from here to here? Or you can also think about it, how do you get from pi up to that one? That's the way I would go about it. I would say, okay, it's not quite to pi, but I know that my reference angle is whatever this was, right? Whatever this radians was. So minus our 0.6898 is going to give us this angle that we were trying to find. Okay, so we do pi minus that answer. What do you mean syntax error? Oh, I did negative, no wonder. There we go. So it's about 2.4518 radians for this other one. So there are actually two angles in this case. Now there aren't always, it depends on the situation. But keep in mind that if we're going from 0 to 2 pi, there's almost always going to be 2. Okay. Let's do another one. Cosine is equal to negative 2/9. So the negative tells us that which quadrant we need to be in. So negative 2/9 could be, okay, so it can't be here. Can't be here. Or no, sorry, it could be here. It can't be here. Wait, nope. Could be here, cannot be here. Because all students take calculus, these two are where sine or cosine is positive. So it could be in one of these two. Okay, I don't know which one. So what we're going to do is we're going to go ahead and draw our angles. So this would be how we do it. This would be our theta, or our x. Okay, we can call it x. And cosine is negative 2 over 9, so that means our adjacent sine is negative 2, and our hypotenuse is 9. And the fun thing about this is this actually creates this exact same triangle down here, okay? Because negative 2 is still that side, and then 9's up here. And then I don't know what this is, but I know it's y and negative y respectively, okay? So when we are trying to do this, then we would say, well, let's take the inverse cosine of both sides. Okay, and we would get x equals whatever the inverse cosine of negative 2 over 9 is. Now this one will give us that positive one. Okay, so it's going to be 1.7949. That gives me this one. Okay, but this would actually be negative x in a way. That's a bad way to say that. But we have to think through, how do we get this other one? Because we found this one. We're good on that one. But we also need this one. Okay. So what do we do with this? Right? How do we deal? Okay. So the answer is that this is one of them. This is. Okay. You can circle that one. That is one of them. But how do we get the other one? Okay. So how we do it is we take all of the 2 pi and we subtract that answer that we just got. Okay. So let me do that one. So x also equals about 4.4883 radians. So just to kind of show you guys, so that's at like 1.4. So think about where 1.4 would be in the grand scheme of this, like as far as pi goes, right? Because this is 2 pi, this is 3 pi halves. So I want you guys to think through. This is like 4.7. This is like 6.28. This is like 3.14. This is, let's see, pi halves, it's like 1.6-ish, right? So if we're saying it's at 4.7, or 4.4, I'm sorry, then that makes sense for it to be here because it should be between 3.14 and 4.7. I hope that helps you guys think about like where they should be when the radians don't have pies, because I know that's cognitively just like a little bit weird to think through where things would be. Okay, so those are your two answers. I'm not going to go over the rest of these, but I will post the complete notes with them, with the answers and everything. But I want you guys to go ahead and try them out on your own, and that does it for 6.1.